Hello there, this video is about calculating or finding the arbitrary constant of integration. In our earlier video, we had talked about differentiation, and then we have also looked at integration, but we are going to look at the process of finding the arbitrary constant of integration. Therefore, we will be finding the particular y function or the curve which initially probably has been differentiated and then given the derivative or the gradient function. So in the reverse process of integration, we will find out what the original curve was in the beginning. And that would not be complete unless we have found the constant or arbitrary constant of integration. So it's a quick reminder that integration is the reverse process of differentiation. We have indefinite integrals and we have definite integrals. Before we look at definite integral much later, we will try to find the arbitrary constant of integration and then the original curve or original y function that probably the gradient function was gotten from. So let's look at the rule of integration. We have that the integral of a function x to the power of n, as we have here, the integral of function x to the power of n, as we have here, will give us x to the power of n plus 1. That is, we're going to add 1 to the power of the n, the power of the x, and then the new power, which is n plus 1, will divide the entire function by the new power. So we divide by n plus 1. In the same way, if we have the function, having a constant attached to it, of course, in this case now we have represented our constant with a. So what we do is that we're going to go ahead and apply the same rule. The same rule that we have used for the a applies also in this case, just that you're going to be having a x to the power of n plus 1, all divided by the new power, which is n plus 1. Then we add our constant c to it. So take note that this rule applies when the value of the power n is not equal to 1. That's when this rule applies to our function that we intend to integrate. So let's take note of that. Now let's move forward to applying this rule. Now if we have a constant, for example, 7, and we have to integrate the constant 7, of course, that will mean the integral of 7 times x to the power of 0 with respect to x. Of course, that's the same thing as, that will give us, that will give us 7x to the power of 0, integrating that with respect to x, that will give us 7x, 0 plus 1, all divided by 1. So the calculation of that will give us 7x as our answer, then plus c. So in this case, it means that we have y as 7x plus c. So that's the y function or the curve that results from the integral of 7. Now, what this means definitely is that if we are actually asked to integrate something like 5 with respect to x, this is another constant, the result will give us 5x. If you are integrating minus 2 with respect to x, that will give us minus 2x. So the integral of any constant will give us the particular constant multiplied by the variable x if we are integrating with respect to x. So let's move up and then work out, okay, let's work out this simple one, or this one that's having multiple terms or more than one term. Find the integral of x squared minus 5x plus 1. So the integral of this means that we are going to integrate the different parts of the function. We're going to integrate x squared, we're going to integrate 5x separately, we're going to integrate x squared separately, we're going to integrate 1 separately. So the integral of this will give us x to the power of 3, x to the power of 3 divided by 3 minus 5x to the power of 2 divided by 2. Then we have plus 1x, which is same thing as x, then plus our constant c. Okay, so this means that our y function is y equal to x to the power of 3 divided by 3 minus 5x to the power of 2 over 2 plus x plus c. But you notice that the c is not found. So this does not give us our full y function. So that's why we said that we will be looking at the process of finding our arbitrary constant of integration, and therefore we would be able to come up with the original y function in full. So let's take note of this that we have just done. So in the next example that we're looking at right now, it is going to be on finding the arbitrary constant. So let's take this first example. We have the gradient of a curve at any point is given by 3x squared plus 4x minus 5. Determine the equation of this curve if the point 2, 5 lies on the curve. If this given to us is our gradient function, of course that means that's our dy dx, then we are told also that the function, original y function we have to find, passes through this point 2, 5. We're going to see how we apply the values at this point, the coordinate values at this point, and then get the original y function having the constant c already found. So let's get to work. We have, let's move this up a little bit. Okay, so we have that our dy dx is given as 3x squared plus 4x minus 5 is our gradient function. It implies that, I'm going to cut this page into 2. It implies that our y function will be the integral of 3x squared plus 4x minus 5. And the result of that will be y is equal to 3x to the power of 3 divided by 3 plus 4x to the power of 2 divided by 2 minus 5x plus c. We can simplify that to give us y is equal to x to the power of 3 plus 2x to the power of 2 minus 5x plus c. Now, when we are told that the curve passes through the point, passes to the point 2, 5, it means that when x is equal to y is actually going to be 5. So if it passes through this point where x is 2 and y is 5, we substitute into our function, and then we have y as 2 as a 5, then we have x as 2. So if I put 2 in x here as 2 raised to the power 3, 2 raised to the power 3, that should be 8. So that gives me 8. If I put 2 here, 2, I need to just write that. We have 2 times 2 to the power of 3, 2 rather. Then we have minus 5 times 2. And then we have a plus c. Now, if you evaluate all of this, you're going to have 5 equal to 8 plus 2 times 2 is 4 times 2, that's another 8. then we have minus 10, then we have plus c. Now, if we evaluate this, we solve all of this, that will be 16 minus 10, that will be 16 minus 10, that will be 6. If you work this out, you get our c, and work that out, you find out that your c is going to be equal to minus 1. So if c is minus 1, then we can have that our equation of the curve will be y equal to, remember we have it simplified here as x raised to power 3, so we have x raised to power 3 plus 2x squared minus 5x plus c, and our c has been found to be minus 1, so that will be minus 1. This is the equation of the curve. Is the equation of the curve. So we are done. We are going to try and take another example.